Preparing for a Linux administrator at MUFG interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you troubleshoot a Linux server that suddenly becomes slow during banking business hours? I start by confirming scope and timing, then use uptime, top, vmstat, iostat, free, ss, and sar to identify whether CPU, memory, storage, or network is saturated. I check system and application logs, process states, and recent deployments. For a production banking server, I avoid impulsive restarts, capture evidence, follow change procedures, and engage application owners. After stabilization, I document root cause and add monitoring or capacity planning to prevent recurrence. While answering, focus on defining the symptom, checking load average, CPU, memory, disk I/O, processes, network latency, logs, recent changes, and safe remediation without disrupting critical financial services. Question 2. Explain Linux file permissions, ACLs, and how you would secure sensitive financial data. Linux permissions use owner, group, and other access bits, represented symbolically or numerically, such as 640 for a sensitive file. I apply least privilege, restrict directory traversal, set an appropriate UMask, and avoid broad permissions like 777. When standard groups are insufficient, I use setFACL for precise access. For MUFG-like data, I combine permissions with encryption, centralized identity, audit logging, periodic access reviews, and controlled service accounts, because permissions alone are not complete security. Make sure to cover owner, group, read-write-execute bits, numeric modes, UMask, setwood risks, POSIX ACLs, least privilege, service accounts, auditing, and secure handling of confidential transaction data. Question 3. How would you investigate repeated SSH authentication failures on a production server? I inspect journal.ctl, secure, or auth.log entries, depending on the distribution, and correlate source addresses, usernames, and timestamps with SEAM data. I determine whether failures indicate a compromised account, brute force attempt, expired credentials, or an automation error. I verify SSH configuration, disable unnecessary password login, enforce approved keys and MFA, restrict administrative access through bastion hosts, and apply firewall controls. I preserve evidence and notify security before blocking anything that could affect legitimate operations. In your answer, talk about auth logs, source addresses, usernames, time patterns, fail to ban or equivalent controls, centralized identity, MFA, key management, firewall rules, and distinguishing attack activity from legitimate operational errors. Question 4. What is systemd, and how would you diagnose a service that fails after reboot? Systemd manages services, dependencies, targets, sockets, timers, and startup ordering. I begin with systemctl status service and journal.ctl service B to inspect the current boot failure. Then I validate configuration, permissions, environment files, ports, mounts, and dependency availability. I check whether the unit is enabled and whether ordering or readiness is incorrect. I test changes in a controlled environment, use systemctl restart only when approved, and preserve logs for incident review and audit evidence. Be sure to mention units, dependencies, targets, enablement, journal.ctl, systemctl status, exit codes, configuration validation, startup ordering, and safe rollback for regulated production environments. Question 5. How would you design high availability for a Linux-based payment application? I design redundant application nodes across failure domains behind a load balancer, with health checks that detect meaningful application failure rather than merely an open port. Stateful data requires synchronous or carefully managed asynchronous replication, consistent fencing, and tested recovery procedures. I include redundant network paths, storage, power, monitoring, and administrative access. The design must meet defined RTO and RPO targets, prevent split brain, and undergo regular failover exercises, because theoretical redundancy is not operational availability. While answering, focus on eliminating single points of failure across compute, network, storage, and power, clustering, load balancing, health checks, data replication, failover testing, RTO, RPO, and operational procedures. Question 6. What steps would you take to harden a newly provisioned Linux server? I begin with an approved minimal image, current patches, secure boot where supported, and removal of unnecessary packages and services. I configure SSH with restricted access, key authentication, controlled ciphers, and administrative separation. I enable SELinux or APARMOR, firewall D or NF tables, time synchronization, endpoint monitoring, centralized logging, and vulnerability scanning. I apply a documented baseline, verify file integrity, test backups, and record exceptions. Hardening should be repeatable through automation, not dependent on manual memory. Make sure to cover minimal installation, patching, secure SSH, host firewall, SELinux or APARMOR, time synchronization, service reduction, vulnerability scanning, logging, backups, and configuration baseline compliance. Question 7. How do you manage Linux patching for systems that support critical banking applications? I maintain an accurate inventory and prioritize patches by exploitability, exposure, business criticality, and vendor guidance. Before production, I test updates against application dependencies in a representative environment and use canary hosts where possible. I schedule approved maintenance windows, verify backups, define rollback procedures, and monitor health after deployment. For urgent vulnerabilities, I use emergency change processes and compensating controls such as segmentation. Every action, result, exception, and approval is recorded for operational and regulatory traceability. In your answer, discuss asset inventory, risk-based prioritization, testing, maintenance windows, dependency checks, backups, canary deployment, rollback, emergency vulnerabilities, and evidence required for compliance. Question 8. A file system is full on a production Linux server. How would you resolve the issue safely? I first run DFH and DFI to distinguish block exhaustion from inode exhaustion, then use do to locate large directories. I check LSOF for deleted files still held open, because removing a file name may not release space until the process closes it. I avoid deleting unfamiliar files blindly, coordinate with owners, rotate or archive logs, and extend storage only after understanding growth. Finally, I correct retention policies and alerts, then document the incident and capacity trend. Focus on DF versus do, deleted files held open, inode exhaustion, log rotation, temporary files, snapshots, growth trends, safe cleanup, application coordination, and prevention through monitoring and quotas. Question 9. How would you troubleshoot high memory usage and possible swapping on Linux? I use FreeH, VMSTAT, top, PS, and proc, meminfo to separate genuine pressure from filesystem cache, which Linux uses efficiently. High swap in or swap out activity indicates performance risk, while an OOM event appears in kernel logs. I identify the responsible process, examine growth over time, limits, and application behavior, then coordinate a controlled restart or workload reduction if necessary. Increasing swap or RAM may help, but I also pursue leaks, incorrect limits, and capacity planning. Be sure to mention free, VMSTAT, top or PS, cache interpretation, swap activity, killer logs, process limits, leaks, workload behavior, and remediation that avoids masking an application defect. Question 10. What is your approach to Linux backup and disaster recovery for critical systems? I define RPO and RTO with application owners, then protect operating system configuration, application data, databases, secrets, and monitoring definitions appropriately. Backups should be encrypted, access controlled, versioned, retained according to policy, and stored across failure domains, including immutable or offline protection against ransomware. Database backups require application-aware consistency. I test restorations regularly, measure recovery time, and update runbooks after each exercise. A backup is only valuable when the organization can reliably restore and validate service. While answering, cover backup scope, consistency, encryption, retention, off-site or immutable copies, RTO, RPO, restoration testing, database coordination, access controls, and documentation of recovery responsibilities. Question 11. How would you troubleshoot a Linux server that cannot connect to another internal service? I establish whether the failure is name resolution, routing, transport, authentication, or application level. I use get and hosts or dig, ipaddr, iproot, ping where permitted, ss, nc, curl, and traceroute selectively. I verify the destination listener, local and remote firewalls, security groups, SELinux denials, certificates, and service logs. If needed, tcpdump shows whether packets leave, arrive, and receive responses. I compare a working host and preserve timestamps, commands, and findings for network or application escalation. In your answer, cover DNS resolution, routing, interfaces, ports, firewall rules, TCP testing, TLS, service listeners, security controls, packet captures, and escalation based on evidence rather than assumptions. Question 12. How do you automate Linux administration while maintaining control and auditability? I use version-controlled automation, commonly Ansible, to make configuration changes repeatable and idempotent. Playbooks define approved inventories, expected states, handlers, validation steps, and limited privilege escalation. Secrets belong in a vault or approved secret manager, never in plain text. I test changes in development, review them through pull requests, use controlled production runs, and capture execution results. Automation improves consistency, but governance remains essential. Every change needs ownership, approval, rollback, and evidence. Make sure to discuss Ansible or equivalent tooling, ID impotency, version control, peer review, secrets management, inventories, testing, least privilege, change approvals, and rollback or reporting. Question 13. What Linux monitoring metrics and alerts would you establish for a critical service? I monitor the service from both infrastructure and user perspectives: availability, latency, error rate, throughput, process health, CPU, memory, disk I/O, file system capacity, network errors, certificate expiry, and replication lag. Alerts should use meaningful thresholds, duration, and dependency awareness to reduce noise. I connect alerts to runbooks, ownership, and escalation paths, while centralizing logs and preserving audit records. For critical banking services, I also define synthetic transactions and validate recovery objectives, not just server uptime. Focus on availability, latency, error rates, CPU, memory, disk, file system growth, processes, network, certificates, replication, log patterns, alert thresholds, dashboards, and actionable escalation paths. Question 14. Explain SELinux and describe how you would investigate an access denial. SELinux is a mandatory access control system that restricts actions through policy, even when traditional permissions allow them. For a denial, I inspect AVC records with AuthSearch or Journal CTL, use SELert for interpretation, and check labels with LSCI correct-incorrect contexts using RestoreCon, adjust approved booleans or policy when justified, and retest. I do not disable enforcement as a shortcut. Any custom policy should be minimal, reviewed, documented, and validated against security requirements. Be sure to mention enforcing modes, labels, contexts, AVC messages, ASearch, SELert, restorecon, booleans, policy principles, and why disabling SELinux is not an appropriate default fix. Question 15. How would you investigate a suspected Linux security compromise? I follow the incident response plan, notify security, and avoid actions that destroy evidence. I record volatile information where authorized, review authentication logs, running processes, network connections, scheduled tasks, startup units, file changes, and privilege escalation indicators. I isolate the host using approved controls while preserving business continuity and forensic integrity. I never trust a compromised system for remediation. Depending on evidence, I rebuild from a known good image, rotate credentials, validate backups, patch the root cause, and document lessons learned. In your answer, cover containment, evidence preservation, authentication and process review, persistence mechanisms, network connections, integrity checks, escalation, forensics, rebuild decisions, and communication through the incident process. Question 16. What is your experience with Linux storage, LVM, and file system expansion? LVM separates physical storage from logical volumes, allowing flexible allocation through physical volumes, volume groups, and logical volumes. I verify free extents with VGS and LVS, extend the logical volume carefully, then grow the file system using the correct tool, such as XFS growths for XFS or resize 2FS for ext4. I confirm backups, mount points, and application impact first. Snapshots can support short-term testing, but they consume space and are not substitutes for reliable backups. While answering, discuss physical volumes, volume groups, logical volumes, file system types, online growth, snapshots, capacity checks, backup considerations, and avoiding irreversible operations under pressure. Question 17. How would you manage privileged access for Linux administrators in a regulated financial environment? I prohibit shared administrator accounts and require named identities integrated with centralized authentication, MFA, and controlled bastion access. Sudo policies grant only necessary commands, with time-bound or just-in-time elevation where available. Administrative sessions and commands are logged centrally, while sensitive credentials remain in an approved vault. I separate approval, execution, and review responsibilities, maintain a tested break glass process, and perform regular access recertification. Departures or role changes trigger immediate revocation, not merely a later review. Make sure to cover named accounts, sudo roles, MFA, bastion access, just-in-time privileges, session logging, separation of duties, break glass procedures, periodic reviews, and immediate access revocation. Question 18. How would you diagnose a Linux server that fails to boot after a configuration change? I obtain console access and identify whether failure occurs in firmware, bootloader, kernel, initramps, or systemd. I review the previous boot journal, attempt an earlier kernel if appropriate, and use emergency or rescue mode to inspect FSTAB, mount dependencies, permissions, and recent configuration changes. I make the smallest reversible correction, such as restoring a valid mount entry, then reboot under observation. After recovery, I validate services, document the failed change, and improve pre-deployment testing and rollback procedures. In your answer, cover console access, boot targets, emergency mode, journal logs, FSTAB, initramps, kernel parameters, grub recovery, rollback, rescue media, and change control evidence. Question 19. How do you handle a production incident involving multiple teams and conflicting priorities? I establish or accept an incident commander, state business impact, and separate coordination from technical investigation. I provide concise updates covering facts, current hypothesis, actions, risks, and next checkpoint. The team prioritizes safe mitigation, such as failing over or reducing load, while avoiding unapproved changes that could worsen financial processing. I maintain a timeline and assign owners with explicit outcomes. After restoration, I lead a blameless review that produces specific corrective actions, owners, deadlines, and verification metrics. Focus on incident command, impact assessment, communication cadence, evidence-based hypotheses, safe mitigation, escalation, change approval, stakeholder updates, post-incident review, and measurable corrective actions. Question 20. Describe a Linux administration improvement you would propose for MUFG's large-scale, highly regulated environment. I would propose a standardized, hardened Linux platform built from versioned golden images and managed through infrastructure as code. It would include approved packages, security baselines, centralized logging, monitoring, vulnerability reporting, and automated drift detection. I would pilot it with a low-risk service, measure provisioning time, patch compliance, incident frequency, and audit findings, then expand through governed releases. This balances engineering efficiency with MUFG's resilience, security, and regulatory obligations, while preserving documented exceptions for legitimate application requirements. Be sure to mention standardization, golden images, infrastructure as code, configuration drift, observability, security controls, resilience, measurable outcomes, stakeholder alignment, and phased implementation with governance. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.